Okay, welcome back, everyone. I apologize for that crazy nonsense, and for the crash there. So I just rebooted, and we're gonna jump right into this. So just to recap, um, for those that'll be joining maybe later on watching this content for the live stream, I will be making a video on this. So if you haven't, go check the channel to make sure that there isn't a pinned video specifically about this. But if there isn't, then the live stream is the current version of this information. So I'm trying to make this as clear cut and digestible as physically possible. So I'm hoping that we can just kind of jump right into this and get started. Let me just make sure that I share this content on social media real fast, and we'll get good. We'll be good to go. All right. So sorry, I'm just kind of idly typing away here. But we should be ready to jump on this. Let me just post it and should be good to go. All right. Let me close this down and we should be good to go. I think everything is skookum. I think we're squared away here. So let me get started with just a brief introduction to what I'll be doing here, and then I'll jump right into it for those that are joining us later. So, um, thank you guys all for humoring my startup here. Um, so this video is a live stream about how to get ready for the Game Jam season, specifically for Game Jams with GDevelop. Hey Riley, thanks for joining us. So yeah, so this is the live stream for the Game Jam Ready video series for GDevelop. So in this, we're going to be jumping into creating games within a limited time frame. And I think that GDevelop is perfect for this because it is a no-code visual programming interface and language that allows you to very quickly prototype your development. So for those that are maybe unfamiliar with game jams, let's just jump into this real quick. Um, Game jams are typically an online or in-person event where developers come together to create games with a specific theme or limitation in mind, and usually it's over a short period of time. Relative, sometimes it's 48 hours, sometimes it's a week or longer, depending on the jam. But usually the in-person or online jams are roughly 3 days long, 2 or 3 days long. So 48, it was 48 to 72 hours. And what they're usually about is with them, with every game jam, there is a theme or a limitation generally, and that adds a little bit of variety and flavor to what we're trying to do. Now, the intention of putting these limitations for game jams is because we want to boost your creativity. We want to think outside of the box and come up with innovative ideas under pressure. We want to connect with connect with the community. So collaborating with developers, sharing your idea, and getting inspired. If you are entering game development right now for the first time in your life, and maybe you're young, or maybe you're a seasoned pro, I think that it's important to remember that game development is an art form, and so it needs practice, and it also needs you need to take the time to build those skills to become efficient at it and to understand the concepts around it. And so a big part of that is using references and networking with people, getting user feedback, getting feedback on your work. And the best way to do that is to put yourself out there and join the communities now and get comfortable doing that before you jump into a big game jam setting or something like that. But these jams are also developed to sharpen your skills, to push your boundaries and learn new aspects of game development, whether it's in the communication side, or maybe you're an artist, or a programmer, flexing on different types of programming, different skill sets. These jams let you micro manage those, sort of like jumping into them and get a micro experience and start building the foundations for your game development skills through that. And so it's about repetition and just getting that hands-on experience. And then also, I think more importantly than anything else, is about having fun. This whole thing, game development should be fun. And if you're not having fun, we should address that and make it more fun. So that's what we're aiming to do kind of in this video, is take off some of the stress and teach you some tips and tricks and give you some pointers on how to participate in a game jam. So I've got my water here with me because I'm going to be speaking quickly and a lot. So let's move over here to our main display. Now, let's see here. I didn't think that chat was going to stay on screen forever. So I think what I'm going to do for now is just hide the chat and push that to you guys. There we go. Okay, so before we get started in the crash course of GDevelop to get you the skills necessary, I want to explain to you why I'm choosing GDevelop. GDevelop rocks for game jams, and you might be wondering why. Well, compared to complex coding structures or game making languages, just coding languages in general, they're immensely complicated, and there's a lot of things that you might feel like you need to know, or you do actually need to know them to be able to program, and it requires a lot more investment of your time. But with GDevelop having a no code visual scripting style, it means that instead of writing lines of code, you can drag and drop elements to prototype very quickly. And so GDevelop is very user friendly. It's very intuitive and easy to learn. It's very fast at prototyping. Like I said, you can experiment and iterate over your game concepts very quickly, and that's very critical for game jams. And then it's surprisingly powerful. Don't let the ease of use fool you at all, because GDevelop offers a surprising depth of features to create a variety of different game genres. So one of the biggest things that people overlook, and this is what we're going to be focusing on in this particular video, it's getting a head start with boilerplate code, and how to do that in GDevelop, and what I mean by boilerplate code. So for those that don't know what boilerplate is, imagine having a pre-built system for managing any aspect of your game, from a menu or a basic mechanic that is universal across games. Now, game jams don't let you generally, you have to read the rules specifically, because they do check some things. Like, you don't want to upload a project that you started earlier before the game jam. You do need to, don't duplicate a project. Make sure you start a fresh project. But boilerplate code is copy and paste code that is basic game fundamentals that anybody can make. It's not specialized in any sort of way. And so the reason why we do this boilerplate code and create these templates and structures is so that way when we jump into a game jam, we just have a bunch of code, if we're a programmer, already ready. Maybe we're an artist and we have a bunch of art prepared, right? It's the same thing, same concept, right? What we're doing is we're preparing with boilerplate stuff, and you have to read the rules of your game jam, but mostly this is very much standardized across game jams in general. It's hard to regulate regular written code that is so replicatable that anybody can do it at any point in time. And you don't want to be getting into a game jam and not have any of these ready, because if you do, you're going to spend those hours rewriting the wheel, rewriting the same thing that is constant in all of your game jams or whatever it is. So we're going to be talking about using GDevelop for the purpose of pre-creating these templates so that you're game jam ready by the time the game jam comes. And one of the things that I wanted to bring your attention to is, if you don't know, if you're watching this video ahead of time, May 17th to the 26th is a GDevelop game jam. And we're actually going to click on this and read, just to give you some hands-on experience when you're choosing a game jam, and how to like go about that. So here we have the itch.io game jam for GDevelop game jam number 5, and that'll be starting in wow, the other, wait, did the other 17 to the 26th, 17th to the 26th. There's a bit. All right. Well, that's fine. Anyways, so it starts in 1 month, 29 days, 1 month, 29 days, 22 hours, and 57 minutes from now. And from the time that we're doing this live stream. And if you haven't joined, definitely join. It was just announced a little bit ago. There's 207 people. This is a perfect time for you to get involved. And we can see that they're going to give us 9 days to create games using GDevelop. And we don't know yet what the theme is going to be, but here are the rules. So we can see that you must use the GDevelop game engine to make your game for this game jam. The engine is free and open source. We already know this stuff. If you don't, you can figure this out and go to gdevelop.io to get the application or run it in your web browser. Games must not include offensive, discriminatory, or not safe for work content of any kind. This is an event for anyone and everyone, so don't be rude. Games must be submitted through itch.io for rating, as well as gd.games. So that's an export thing that we have to do, and that's totally fine. Games must be published to be played on browsers. Thumbs up if you have mobile compatibility. That's pretty easy to implement, and I highly suggest everyone does it. GDevelop has a fantastic YouTube, where Helper Wesley kind of manages all of that. And you haven't seen Helper Wesley's channel, go check them out if you're watching this video after, and there's an edit. I'll probably have a link export to that person. So go check out their content. They're awesome, and there's great information available on both GDevelop and through that, as well as inside of the program. There's some easy-to-use toolings that'll help get you started with very basics. So we're not going to cover that in this video because that content is easily available on the front page of GDevelop. Joystick controls. That is the basics of adding mobile support. So between joystick controls, the health bar, using some 3D stuff, figuring out backgrounds and parallax, timers and score multipliers, those are serious fundamentals that you should do. So that way you are game ready. So complete these if you haven't. I have other accounts, or have gone through other accounts, so that's why it's uncompleted here. But you should do that because they're very short and they will teach you concepts that are critical to game design. Now, going back to the rules, it must be in English, okay? You may team up. The maximum number of teammates is 4 for this one, and you can join it on the Discord server. So we know that we can have up to 4 people. The game itself must be made within the jam period and must not submit any work or updates during the community voting period, nor during the judges voting period, 3 days after the games are submitted in the end of, or after the community voting ends, sorry. So you may use pre-made, publicly available and purchasable assets, as well as GDevelop's built-in asset library or any other assets that you have legal rights to use just remember to credit properly, and you can use pre-existing code, extensions, functions, but do not write code specifically for the jam ahead of time. And so we can see example cases here, and they very, very easily and conveniently lay this out for us. So we can use UI elements, private extensions, short snippets, and events like game juice, for example. And what we're not allowed to do is reuse any existing project with changed art assets, reuse any existing project with minimal changes, and submission of a project worked on prior to the game jam, because they can check that out. So that means that we need to build boilerplate code, and that's what they're saying that we can use here, these short snippets of code. And so I'm going to show you how to prepare that today. So here we go. So I'm going to jump in today and start teaching you the most fundamentals of GDevelop that makes you game ready right now for the jam. So I'm going to teach you a concept called finite state machines. And I'm going to get a drink of water here before I begin, because this one's a doozy. So we're going to get... Hey, Remy, how's it going? Thanks for joining us. So, today we're going to get a head start with the boilerplate code, and we're going to do probably one of the most extensive things that you could possibly do in GDevelop, and in my personal opinion, and it's a great habit to start building right now, because if you're brand new to GDevelop and you need a place to start, this will teach you not only a way to organize your code, but a way to develop games that help you debug faster and get into the scripting side or the prototyping very quickly and easily. And it makes most of your code modulated, so that way you can reuse it and move it around and use it in other projects. Super simple. So because GDevelop on the desktop version, and I'm specifically using the GDevelop desktop version because I'll be saving these files into a desktop backup or a thumb drive where I can make sure that I don't lose this boilerplate code if anything ever happens. So store it wherever you want, but the reason why we're using the desktop version is because I can save an unlimited amount of desktop applications because they're not hosted on the GDevelop cloud. So to do this, we go to our build section, and we go to create a project. And for this project, we can change the viewport and canvas size at any point in time. But we're going to start with a generic mobile and desktop landscape 720. And let's see, actually. We're going to do 320 by 180. And the reason why I'm doing 320 by 180 is it is at the same 16 by 9 scale as both 1080 and 720. And this allows us to not have to zoom in our project. This is a accurate 16 by 9 aspect ratio. Or like, no. Sorry, this is I lost my brain. Is it 320 by 480? Or before I chatter my face off and say the wrong thing. Yeah, so 320 by 4 is 1280, and 180 by 4 is 720. So if we chose the desktop view, we'd have to zoom in 4 times to get the same aspect ratio as this, or the same size. And so for already developing pixel art, we might as well shrink the game down to the same scale and then just blow it up on export, resize it to the user's screen, rather than having to force scale it in. Unless you want to have zooming in and out in your game project or something, but I'm going to use 320 by 180. And we're just going to name this player. Let's do boilerplate is the industry standard for this boilerplate code, right? Boilerplate, and we're going to say finite state machine or player finite state machine or FSM. Okay. we're going to turn off the authentication, and we're going to optimize for pixel art. You could do authentication, and in a game jam setting, you may actually want to do this, so we can leave that there because it already comes pre-clicked. Sorry, I have the hiccups because I'm speaking so quickly. All right. So here we go. So instead of selecting the GDevelop cloud, we're going to pick your computer. Now, the reason is, again, so we can save this offline and have this as a backup storage so we're ready to use the code whenever we need it. So we're going to choose a new folder, and I'm going to choose my storage folder, and we're going to add a new one and call it, I'm going to call it Game Jam, Game Jam. That's fine, Game Jam. That's Game Jam. Come on, Alex. We need to fix that. Add an E, Game Jam. And then we're going to add a new folder, and we're going to call this boilerplate. Boilerplate. And then we can call this Player Finite State Machine, right? Or we just select this folder, actually. We don't need to go any farther than that. So boilerplate, select, that's good. So now we'll have it as the project is boilerplate player finite state machine, optimize for pixel art because that's what I'm using, and allow for authentication. You can read more about that here if you'd like, but we're going to skip through that and create a project. So now we're greeted with the most basic of, I'm using the mouse wheel in and mouse wheel out to zoom in, by the way, and middle mouse down to move the canvas very quickly, but I'm going to get it centered. You can also right click and just set zoom to initial position, which just centers this in, so you don't have to zoom in and zoom out. So right click and then do that. So this white area, very quickly, is the scene editor, and the black camera border is for the, well, camera or viewport. So the entire thing is your scene editor at large, and then this is the layout, and then canvas / viewport. So everything that we do in our development will be dragged and dropped onto this, more or less. So with that, we have a properties panel, which gives us all the good stats and position and other things that we can interact with each instance of object that we add to the canvas, as well as we have an objects panel, which we can add objects and create sprites and text objects and things like that. So I won't be using any of my art in this video. I will be strictly using what is in GDevelop, so that way everybody can have the same access to this material. So everything's going to be used inside of GDevelop. We're not going to use any external downloads or anything like that. So let's get you started. Let's get you some boilerplate code so that way when you're ready to move into your game development features and game jams, you have at least somewhere to start. You have something valuable to add to a team, or at least have some knowledge that'll get you going. So let's see here. So let me first explain what a finite state machine is. A finite state machine is a way to organize your game's logic based on a state, an object's. Hey, what's going on? Thank you for joining us. I almost called you Funky. Funk you? Funky? Yeah, Funky. Funky, right? Funky? That's your name? Sorry, I got distracted there with that name. My dyslexia kicked in, and then I had to look at it and be like, wait a minute. Is that actually right? I'm not sure. Just Funk? All right, I'm going to call you Funk. That makes actually sense. K, yeah. K, qua, yeah. All right, yeah. What up, Funk? So, with a French accent, so... But I'm from Germany. Well, greetings from America. Hello. Okay. I got distracted. Let me... What was I going to say? My brain got completely derailed there. What was I saying? I got to look at my notes. All right. Okay, so effective. Now I remember what I was going to say. Okay, so effectively, so we're doing a finite state machine boilerplate code. So a finite state machine, or a FSM, is a model used to represent the behavior of a system that can be in a finite number of states at any given time. And finite means restricted, very controlled. So in GDevelop, you may have started your GDevelop journey um where you go to your events and you create something like, let's say we add a player to our scene, right? A sprite. We're gonna go ahead and actually, I don't want to jump over this. I think that now is a good time to just review that. So let me just go through what a finite state machine is, and then I'll explain how to do all of it. So in a finite state machine, going backwards, the model represents a behavior of a system that can be in a finite number of states at any given time. This consists of a set of states. It requires that we know what they are, and it also transitions between those states and with actions and outputs associated with those transitions. That's a lot of talking, but I promise it'll make sense here in a little bit. In a finite state machine, the system can only be in one state at a time. So imagine your player is jumping, right? Jumping is a state. Falling is a state. Moving is a state. Idle is a state. We're already used to these concepts, but we're able to, rather than generically throw these things down, we can finitely, very finely control these concepts and make sure that our game works as expected and keep all of our code organized and in a really handy way. So the transitions, there's a lot more going on there, but finite state machines are widely used in a variety of fields, including computer science, and they're also used to model for behavior, the behavior of programs, protocols, digital circuits. They also are used in areas such as control systems, linguistics, and artificial intelligence. So this is a concept that is universal in language. You can go to any language that you want to use, any game engine that you want to use, right? And use this concept. So I'm going to show you in the most visual way possible because GDevelop is amazing for that. So let's get into that. I don't want to bore you with all the with too much here either. So I want to make sure that you get a really good hands-on experience here. So our story kind of begins with, of all things, a text object. So now this may be the very first time you've ever booted up GDevelop, and you may be joining us for some advanced concepts in your very first time. But I want to make sure that everybody who watches this video has a chance at learning this information. So this might be recap for some of you, and it may be me moving around in my chair, getting comfortable here, and me getting to a point here where I feel like everybody can learn this. So here we are. All right. So we're going to start this journey by adding an object, going down here to the objects panel. And if it ever closes, you can access it up here at the top. So if this closes, right, we need our scene objects because we're dealing with just this. We're going to add an object, and we're going to add a text object. And we're going to call this debug. This is the first thing I always do when I'm building a finite state machine. And the reason is because we use text to visually see and monitor that in real time in this engine. So what we're going to do is we're going to choose we're not going to choose a file. We're going to use the standard debug script, and it's just going to say text for now. Actually, we're going to say debug text so we can see it. We're going to outline it. We'll give it a shadow even, and that should be good. So now we're going to drag that into our game by just simply grabbing it, dragging it, and dropping it. And we're going to position it here kind of at the top of the game screen. Now, right away, we have a situation where we're putting something on. As you can see, here's this canvas, this black line. This is our viewport. So if I hit preview, that text is going to be real big at the top of our screen and real blurry. And that's okay because this style of text isn't really good for how small we're creating our game. So now if we had created a bigger canvas on our game, like the
Level up.
Oh, hey, I really appreciate the subscription. Funk. I almost Funka. Funky. No, I was kidding. uh hey, no, I really do appreciate it. Thank you so much. Wow. Now, the I know your name's Funk. I'm gonna call you Funky now because because it's I find it funny. No, I'll try to remember Funk. Anyway, so the GDevelop text is a bit blurry here, and we can change that. We can make a really refined text later on using bitmap texts. So not BB text, but bitmap text, where we can use actual pixel perfect font and create a really nice look. But we're developing, right, with the idea in mind that we need to do this stuff quickly. So without fussing, I'm actually going to disable some of these features because it makes it look worse, I think. The readability even worse. And now we see debug text. Okay. So we're going to leave that there. But because of where we're putting it on our game, we need to add a new layer. And so the next thing we're going to do is we can open this panel over here. It looks like a bunch of paper stacked on each other. And that's the layers section. We can close the instance list if you have that open. It's this little button here, or you can just close it, no problem. And so I just closed the wrong one. There we go. We have the layers open. And so there's a lot of things we can do here. We can hide the layer. We can lock it so we can't click on anything. We can change some effects, like add outlines and lighting effects if we wanted to. And we can also edit the properties. We're not going to do any of that. We're actually going to add a new layer, and we're going to call this UI. And the reason why that we're creating a new layer is because we want to move our debug from our layer. So we're going to go click on our debug. We're going to go to the objects properties panel, and we're going to go down to the layer section. And we're going to click on that and move it to the UI, the user interface, the layer that we just created. And the reason for it is because our base layer is going to be where we put all of our game features, like our player and things like that. And we may need to move that camera, have it follow the player. Now, every layer in GDevelop has its own camera. Technically, they have multiple cameras, and we can set that up, but they all have a default camera, the 0 camera. And so now UI has a camera that will always stay firm and keep our text at the very top of the screen, no matter what we do with the camera viewport behind it. So we may need to move the base layer's camera to follow the player, but the UI will always stay where it is and always be presented to you as a player. So you can use this technique for making first-person games as well in GDevelop. So once you integrate 3D, you can still use 2D layers to, let's say you're going to make a Doom-style game. Well, your hands would need to be in their own camera, their own layer, so that way you can draw them independently than the game world, so your hands don't move in a weird direction when you're moving in a different direction, stuff like that. So now we have the debug text, and that's the why. I always like to start my game development journey by keeping organized. Man, this chair, so what we can do is we can add some basic components. So I like to do things like make a debug, debug folder. And I like to put various things in there. I like to make an objects folder, objects. We'll put that up top, right? Maybe we have a UI layer that we may need for a menu or other components. So we want to start organizing right away. Now, with this, the very next thing that we want to do is start utilizing the debug feature. So what we're going to do is we're going to go to our game scene or our untitled scene. And actually, just to help, what we're going to do is we're going to go to the project manager. We're going to open it up, and we're going to go down to our scenes. We have untitled scene here. We're going to click on it and rename it. You could just click F2 if you wanted to for quick keys, F2, and we're going to call it game scene. And that way we now have a game scene, and once we press enter, it'll close automatically. Don't stress out. As you can see here, we can actually be in a game project and not even on the main menu. So what we want to do is, and be on the main menu, sorry. So what we want to do is go back up here to the top left, click on our project manager. You can still see we're in the project, and just double click on the scene and it'll reopen for you. We're going to right click and set the position back to the initial position just to keep it nice and tidy and clean. And now we can see when we click on this, it is on the UI layer, and we can just leave that alone. Now, if you are working in layers and there are multiple things on a, let's say we had multiple debug texts for some reason. So I can duplicate whatever's on there by holding Control, clicking, and dragging. I would nod, but you can't see my face, so I'm nodding. No, you're good. And I'm really glad. I'm glad that these videos are helping you. That's what I love. I'm here to help. So I'm a community advocate for GDevelop. For those that don't know me, my name's Alex, and I'm a GDevelop advocate. That just means that I work in the community. I'm a volunteer in the community, and I try to make content for you guys. Try to help level up your game development. So that's why I'm here. So anyways, if you hold Control and drag your mouse around, you can, Control, click, drag, you can create multiple objects. And every time we see one, if it's a duplicate, it'll copy everything that we have here. And so what we can do is, like, if I press 2, for example, now this text will render above this one because it's in a Z order. Z order is the depth of each layer. That's really important to know. So if you have something that's like overlapping in a weird way and you need to figure out why, you can click on it and change the order, or you can shift click, select them all, and change them to wherever you want, and each of them will get changed. But now if I change this one to 1 and click on the other ones, these are each their own instance. So imagine that these were like barrels in our game, and this is a barrel, this is a barrel, this is a barrel. Well, this barrel will draw in front of these ones. So if we wanted to overlap them or like create interesting designs, we'd have to make sure that this one draws on top of it. And these go negative as well. So you can go negative or positive in this direction in Z order. So negative would be deeper than 0 is the base. Negative is behind the base, so background, and then positive is foreground, if you think about it that way. So background is behind, foreground is in the front. So we want to keep organized here, but if I was to duplicate this one, this is well, I changed the setting. So let's change that back to 1. And then we're going to duplicate the text. And when I duplicate it, it duplicates whatever was the selected instance. So even if these have default settings, you can change them in the property screen, and it'll change them at runtime. So when we actually initiate the game, it'll swap to the, if we had animations, we could change the animation visibly on the screen. So we can, let's say we had a bunch of items listed in one object, we could flip to the animation that we want. Say we have strawberries and grapes, and we want to go to the grape section, which is animation number 2. We could change the animation here. It would normally be right here. Or we can even change the variables. Maybe the text has a Boolean attached to it. We could change those things in the editor, sort of like you might for something like Unity. For those that are used to working inside of the editor, you can do some things that way. And so now we have our debug text. Excellent. And now it's on the UI layer. Great. Now we can make sure that it's drawn in front of everything else and make sure that there isn't any overlap in a weird way. So the next thing that we're going to do is go into our game scene events. And like I said before, we can deactivate or display the activation banner or have player authentication. We're going to highlight that and just delete it, because that's the same thing as going to your project and turning it off, or when you created your project, not clicking that player authentication thing. So we can just remove it immediately. We can add it back whenever we want. And we're left with at the beginning of the scene. Great. So at the beginning of the scene, this is the beginning of our game code. What do we want to happen at the beginning before anything else loads? What needs to happen? Now, so in GDevelop, I want to briefly run over the events section because this might be completely new to you. So there's a lot of shortcuts and key control commands to do this, but I'm going to try to make it as simple as I possibly can for you. And so we're going to start with one of the most important features going forward in our organization is we call groups. In this case, event groups. So we're going to go down to add a new event. We're not going to click on it. We're going to right click it. And then we're going to add a event group. And that's going to add this nifty little drop down that works kind of like a comment, but instead you can put things underneath it. So comments inside of GDevelop can't be moved. So if I come over here and click add a comment, I can move this around, but you can't add things like a parent underneath comments, as you can see. I can't do that, but I can move it underneath like this. So comments can be organized differently than these event groups. These really are just tabs, folder tabs, for you to create whatever you want. So again, up here's how you add a comment. You can also Shift W to add an event or select something here. It's the same thing as right-clicking. So Shift W, event group. Look at that, super easy. So now now what we're gonna do is Control Z and make sure that we're just at this basic group. And at the very beginning, we're gonna say game setup. So this is just the very beginning of our setup. These are all the things that we're gonna do at the start of our game. So sometimes what I like to do is just for hierarchy purposes, making sure that it's also in the right order, because where you put events in GDevelop matter. We're going to keep the at beginning of the scene events separate from the game setup. So this way we can always see what's happening when we first start the game. And that way we can do very quick edits without having to organize any other way. So everything after the beginning of the scene will be underneath that. You could make an initialize event group if you really wanted to keep it organized. It's up to you. But this is how we begin. So in GDevelop, we're going to start by adding our first event, which is much similar to the one that it comes pre-built with the at the beginning of the scene and empty, or it had the originally it had the player authentication banner there that we removed. So what we're going to do, forgive me for downing water here. So when we first create something, and we can, by the way, under the event groups, if you want to, we can click the arrow and it'll just hide it for you. That's what makes this so valuable. So we're going to start with this. So right now, this event is outside of the game setup, and that's totally fine. We don't need to move it there yet. I want to show you what an event does and how you can use them. So we have a condition and a action. I would like to reframe this in your head and explain it a little bit different. Let's say this is, the condition is, I would say condition or like the setup and then the sequence of events that happen. So this is the condition in which we're going to set up. The condition is if this happens. This is kind of always an if statement. If this happens or if this doesn't happen, or when these keys aren't pressed, whatever the condition, the trigger is. We have a trigger and then we have a sequence. So we have a trigger and then the events that happen after the trigger is set. So, so we can add a condition by just clicking on the condition, and we can see all of our objects first. So whatever objects we have that have behaviors or anything attached to them, or any scripting that's done to them, could be accessed through the condition menu. So we have a side of, and there's two sides to every object. There's objects like when they have trigger events, so when the player does something or when this happens, does this. And then we have the action side of the things, and some behaviors have conditions and actions. Some of them just have actions, some of them just have conditions. And you may have to dig around in here. Generally, the search bar is perfect for finding those things out when you know what to look for. So, for example, we know that we can type at the beginning of the scene and get that every time because we know what it does now. It's a single condition that runs one time. So there's also a condition that says trigger once while true, but for this particular setup, at the beginning of the scene is a trigger once while true. It's pre-built into the engine, so you don't need to add a if it's trigger this one time. It's only going to trigger once anyways. So with a if there's an event sheet that doesn't have a condition, it means it's running constantly all the time. So what I want to do is set up our debug. So what we're going to do is we're going to leave game setup here. You could copy it if you wanted to or duplicate it, but we're going to if you click on the very top up here on the left edge and click Control C and then Control V, you'll duplicate an event. And right now, I'll just name this empty event. My dyslexia is getting the better of me. And that way we can just duplicate this. So we're going to Control C, Control V, copy paste, right? And then we're going to name this one camera events. So this is the beginning of our finite state machine. This is really important. I'm going to teach you something that's going to blow your mind and make your game development journey so much easier. You guys ready for this? Super simple stuff, but it is revolutionary. So over here in the project manager, we have scenes, right? You're probably familiar with them by this point in time. I just kind of bounced through it a little bit, but the game scene is actually a single object that's comprised of a external event and a external layout. So imagine that this event sheet is a external event and this game scene is an external layout. Now, when you create a game scene, you create an independent layout and script event that pairs together and creates the scene, right? So when we add a new external event, we can call this camera manager. So camera manager is now our external event. Now what we're going to do is we're going to add an external event to our main game. And how do we use scripts and pull them into our game? It's super simple. Watch this. All we have to do is we click on camera events and we can add a comment here and we're going to say when the game, let's say actually include the camera manager script, right? And so that's just our comment. That lets us know what we're doing. And then what we're going to do is we're going to right click, add a new event below. Shift A is the key. And now we'll see that it just pops in right underneath it. Now, if you click on the camera script and hit Shift A, it'll automatically create underneath that. And depending on where you are in the hierarchy, if I select this condition and hit Shift D, this will send it as a dependent, a child of. So Shift D to drop in, Shift A to make it at the same level of hierarchy. So we can keep tabbing downwards. And just like in other programming languages, as you're doing loops and things, you need to think about the same structure. So this happens first, and then this happens, and then we cascade down those events. And that's how we branch off. So now what we're going to do, though, is from this empty condition, we're going to right-click on it, go to Add, and we're going to add Link External Events. We click that, and now we can see if we drag this up, I'm just going to move it so it makes it nice and organized, include events from an external event. We're going to click on it. Now that we've made the camera manager script, we can select it, and then we click this button to jump to it. You could you can click on it from here, or you can click on it directly from here on that little button. It pops out, and it says to edit the external event, choose the scene in which it will be included. What this means is when you choose the scene, you're basically partnering. Think of it in coding. You have a global scope and you have a local, or you will call it global and like closed group. And so global means that you can access this information anywhere from any different part of the engine inside of wherever. Now, when we add an external event, it asks us what project area do we want to include that script in to make sure it runs properly. We're going to choose the game scene because you have to assign it to a game scene. What scene is this code going to be used in? Okay, we're going to make it for game scene and we're going to link it, which now means they're interlinked. So they're linked here. So include the events here, and it'll guarantee when you open it up that this code will run on the next part inside of here. So now we're going to create a camera script for the beginning of our game, or a camera manager. And so I like, inside of the camera, I like to manage all of my UI stuff. So we're going to add a new event. We're going to right click. We're going to add a new event group, and we're going to call this UI elements. So we're going to create an empty, so Shift D, and because we want to create it underneath, if you did Shift A, just drag it in, right? Just add your condition in. And we're going to say, for the UI element, at the beginning of the scene, so at the beginning of the scene, because what's going to happen is it's going to pull this script into the game, and we want this to happen once. We could just say trigger once, right, and add a condition for it, but at the beginning of the scene, as soon as this script gets run, trigger this. So that's when beginning of the scene happens for this script, whenever it's called into play. So as soon as it's called into play, what do we want to have happen? Well, we want the debug text to be hidden at the starting of the game. So we have no other script running in our game right now, right? So we have at the beginning of the scene, nothing happens. It doesn't matter if we have 2 of these, 5 of these, 20 of these, they'll all still be run at runtime at the beginning. You should keep only 1 of them per event script, though. That's important. So then what you want to do is press preview. And now, when we preview the game, it's gone. We know it's running, right? That font is gone. If I delete this and press preview, we see that it's come back. It's there. So we know it's working. We can just Control Z to go back. Perfect. And now at the beginning of the scene, this happens. Well, we want other functions to happen. So we want to check. We want to make it so that when the player presses a keyboard key, something is going to happen. We want to add a condition and say key when a key is pressed. Key pressed. Okay. Well, what do we want the key to be? I'm going to say num for numpad. Well, number 0, 1, 2, these are like your regular keys, 0 through 1. And then we have the numpad. And I want to use numpad. We'll say add. And so we're going to do, if the key is pressed, add, do this thing. And we're going to do this once while true. Okay? When it's pressed, do this one time. Don't continuously run the script. If we don't add a trigger once this is pressed, this goes into effect and it'll just continuously run this thing. We don't need to stress out our game already. So make sure we add a when touch to do this once. And what are we going to do? We're going to show. And we're just going to go over here, copy, Control C, paste this. And then we're going to say when number instead of add, we can remove some number or some text there and say either return, or in this case, we're going to use subtract. And we're just going to copy the hide dialog, Control C, or debug rather. And then we can paste the action down there and delete the show. Make sure you delete show or that won't work. And we can press preview, open our game, press the plus sign, plus the minus sign. And now we can show our debug text whenever we want to. That's huge because that means that as we change things, we can have the debug text change to show us information that we want to know. And that's why I always start with the debug. So that's the basic UI elements. We can define this a little bit further, right? Good practices to keep our stuff super condensed and super readable. So UI elements, we're going to say this is the debug manager. That's what's going on here. debug manager, we can just drag this underneath it. And now we know in our debug manager section, we've got our debug code. Now, you might not want everything to be blue. There's a really easy way to duplicate this, right? So, sorry, not duplicate this. Sorry, to format this in the way you want. So we're gonna go over here and click Open Settings. Nope, wrong. Don't do that. That's the wrong thing. We're gonna right-click and click Edit. Sorry, we're gonna right-click and click Edit, and we're gonna change the background color for debug to be red. And now we're gonna hit Apply, and now our debug manager is red. So we can now start teaching ourselves anytime we do something at a system level. Let's make it red. Let's make it yellow. Whatever your color is. Find a color method that works for you. But for me, debug is generally purple or red. Now, red systems I like to make critical, so I'm actually going to change this personally over to a purple color, because for me, debug elements are neutral. They're things that we need, but and that are useful to have organized, but they're not like a major feature in our game. So purple's kind of a nice color to throw out there that generally isn't associated with like critical systems, or green for go, yellow for slow down, that sort of stuff, you know? Okay, so now we have the core feature of, I'm just gonna actually, sorry, I'm gonna delete game setup, and I'm gonna duplicate, I guess that was redundant, didn't need to do that. We're going to keep our empty. Yeah, Riley, you have a good one. Thanks for stopping in. I see that you're over there on Twitch. I was paying attention. Yeah, it's also going to be available on YouTube, but I'm going to cut this down into a sizable video that taking the information and footage from here to make a final edit. So take care of yourself, and thanks for joining us. Funk brought up something that's kind of important. Control and left mouse, you can drag conditions over. So just so you know, rather than copying and pasting like I did, you can just left click control and drag it in the same way, just like you do when you do in the scene editor, like copying like this. Control and click drag is the way to do that, and it works in the back end as well. That's important to know, just so it's I actually didn't know that, which is wild, but it makes sense that that you can do it in both. Yeah. So, camera events. Okay, so in the new event, we're gonna call this player mechanics. So player mechanics, player, you can say player whatever. I like to say actually player manager, because all of my game stuff is usually run underneath a startup script. So the first thing we're going to do is to make this super clean. Now, again, with finite control, we can compress everything down. Now, you could do this in one script, but just to continue, you may want, oh my goodness, I guess I lost my train of thought there. You may want to break it down into multiple scripts and keep it as refined as possible, or you might want to, make a big script, but you want to avoid spaghetti code. And so for me, organization is really important. So I'm going to go over and beyond just so I can show you how I like to organize, and hopefully this will help your team have a visual flow to make sure your game comes out on time. So what we're going to do here is in the player manager, we're going to add a new external script, and we need to add that down here. So I know that we're going to need the player finite state machine. That's one script. I know that we're going to need the player, the initializer, init. So player init is generally one script I like to run. And then we're going to do player idle. We're going to do player move. We're going to do player jump. And we're going to leave that for now. So player finite state machine, player initializer, we can just drag these around to reorganize them in any way we want. We might want our managers at the very bottom. Frequently used should probably be put up top. And for now, the player finite state machine is going to be the most important in those. This is where we're going to route and control all of our states, but then we're going to initialize a script here. And there's intention with all of this. So just follow along here, and I'll show you how to make your finite state machine. So we're going to start with the player initializer. So this is the first script that we engage our player with. And the reason why is I want to pull you off this page into another page that is just so you can manage the start of your character. So we're going to add we're going to add a comment, a condition, beginning of scene. Okay. At the beginning of the scene, I want this to do a player loop. So at the beginning of the scene, actually, we don't even need that. We're going to do a condition. Oh, we don't have a player yet. So actually, I need to do that first. So my bad, disorganized a little bit. We're going to go back to objects, and now we're going to add our very first object. Okay. We're going to add an object, and we're going to go to the asset store. This allows us to pick characters and assets from bundles and other things, and some of them are premium and some of them aren't, so you may have to pay for some of them, but we're going to choose ones that you don't have to do that for. So one of the things that we can do, rather than finding a pre-built object in here, one of the other ways that you can do that is go create a new object from scratch. If you want to learn about objects, again, all of these videos in every category you go to on GDevelop, there's going to be a handy little digestible video. You should watch those. Click on that and watch that. Now, anyways, so what we're going to do is we're going to add a sprite. This is a player object or whatever we want. We're going to call this player. Okay? So this is our player in every way. We're going to import an image, and it's going to ask us if we want to do it from our... Hello. Wait a minute. Oh, sorry. Let's see. Import an image. Create with Pisco? What happened here? There we go. So once you create... that's what happened. All right. I forgot how to do that for a second. So when you import an image, you can hit cancel. Or sorry, when you... Not... Create with Piscal. Jeez. Come on, brain. When you click with Create with Piscal, it's going to open this up. Okay? You can just click Save if you want to, and it'll just create this little sprite animation. Right? Once you have an animation, we can delete the selected, so there's nothing there. Delete the empty file you just made, the empty sprite. And instead, we're going to go to Add Sprite. And instead of clicking on the plus, we're going to go Choose from the Asset Store. And this gives us a drop-down where we can search for all sorts of stuff in a more convenient way. It's disorganized for an engine that is user-friendly. This search part bothers me. It needs to be addressed, in my opinion. But so what we're going to do is we're going to go maybe some modern sprites, or we can type hero maybe. No, nothing there. Let's go knight. Oh, I'm in the wrong assets. I go all assets. Let's go player. Okay. We could start with this blue arrow guy. That's fine. These are public domain. So let's see. We want walk. We want like the idle animation. Fall, hit, roll. Is it player standing? There we go. So player standing is the first one. Now, one of the things that we want to do, okay, is once we create our animations, we want to label them what we're going to name our finite state machine. Right? So we're going to name these animations the same thing. So we know that this is idle, for example. And we know we're going to add another animation, and we're going to call this one walk, right? Or run. Run's a, walk, run, whatever. Add another animation, and we're going to call this jump. Okay, and so we're going to do the same thing, though. Go in here, choose from the asset store. We're going to find our player walking. So it looks like there's a multiple frames. So the walk frame, we're going to have to go back in here and add each one. So we're going to say walk, okay, walk 2, add a sprite, walk 3, perfect, add a sprite, and walk 4. And now if we click preview, and repeat it. So make sure you click loop so we can repeat the animation. Click on preview, and now we can see some form of walking animation. What is that? Maybe it's just this one. I think it's just that one. Let me go back to here and make sure. Player walking, walking, walking. One, two, three, four? I guess there's 5 in this one. Okay. Let's preview that. Ooh, I do not like this part. I don't like that one either. These are not great sprites. We're just going to use the first 3. And then for jump, we're going to add player. Maybe they have a jump. You got a jump? Okay. Maybe we should use a different... We're going to use a different player. Because I do not like that sprite at all. Sorry whoever made it. Don't like it. Player underscore. I just saw that other guy. There we go. Let's see. Attack, fall. He's got lots. So we can see here that he's got various states. So there's idle. 1, 2, and 3. So we're going to add idle, add sprite, player, idle, 2, and then again 3. Then we're going to go backwards, add a sprite for walking. So player underscore, scroll down. Is it fall, jump, run? It's run for him. So we can type in player underscore run and then start collecting the right resources. This one's got 8 in it. So this is going to take a second, but we're just going to, I don't think I can multi-select in that menu, which would be nice, convenient. I'm going to raise that up to the staff. Maybe there is a way to do that, and I'm just unaware of it because I normally import my own stuff. So this normally doesn't bother me. 1, 2, 3, 4, 5, 6, 7, and 8. Okay, we're going to loop. So the idle should be a loop. The walk should be a loop, but the jumping should not, because loops, you don't generally jump and continuously go through that cycle, right? So what we want to do instead is click preview, and we can see on the idle, loop, we can see the idle. That's going really fast. We may want to slow that down. There we go. So because there's 4 frames, 0, 1, 2, 5 is 8 frames a second. So we're seeing the animation multiple times. Now for 8 frames, 0.08 seems to generally be the good go-to. And if we click preview again, you can see how many frames a second. So we're not quite doubling our frames like the other one. We could go a little bit faster. Let's say 0.6. And we can see that's 16 frames. That's now, it's a little bit over what we want. 7. So if I went to 7, it's 14 frames. That's closer to double, right? The time. So like 6.5 would be like, 5 or 7.5. Sorry, 7.5 is almost perfect. 7.75. We're getting close to 14. Oh, I'm going the wrong way. 2.5. We're getting close. So that's pretty, I mean, I could just set it to 14 there. I don't know. There you go. Generally, I think that looping, for each frame you have, looping about 4 frames a second. If you have 4 frames, do double this amount. If, so if it's 7 frames, do 14. And that lets you smoothly kind of transition in those animations. And that's just what I found to be true. And 0.125 is close enough. I don't think that running this any slower would do us any good. So like if I did 6, it would feel, I think, too slow compared to the speed of the other one. But maybe you like that speed. It's up to you. But generally double. I think that 8 is usually it doesn't matter how many I have. That's about as long as it's 3 to 4. That's about as much as I do. So then we're going to go to sprite down here and add a sprite, and we're going to find the jump. Now this guy's got a long jump animation, if I remember right. Yeah, jump 4, well, which is fine. That's not necessarily unusual. So 1, 2, keep going, 3, one more. We're almost there, guys. 4. Okay. So here we are. So now we have an idle, a walk, and a jump. We're going to hit apply just to make sure that everything goes well. We're going to reopen our player. And now we're going to go to variables. This is where the beginning of, this is how we tie our player into the finite state machine. So we're going to create a variable and we're going to call it player finite state machine, or you could call it player state, right? And it's going to be a string, and we're going to start it at initialize, INIT, okay? And the reason for that is going back into our debug manager, in our UI elements, sorry, not UI elements, in our player initialize, we're going to add a condition. Now we see our player, check our player, and we're going to check a setting. So we're going to look for a text variable, so a string, and we're going to look at, because we defined the variable already, we defined it as player state. So defining in GDevelop means going into the object or going into the position in the hierarchy or what have you, into variable states and adding in a variable. I could change this to anything and accessed it through the dropdown, but if you want it in the dropdown menu, if I click over here and open the variables, this is opening the player variable immediately because we've selected player already. So it knows to jump to that object. And so we could add a variable here. Now, if we could also say player state and it not be defined here already, but it won't have an initial state unless we add it when it's an instance on the layout. That's messy. We don't want to do that. So to make it super simple, if it is the initialized state, so INIT, and we got to make sure that it's spelt right. I wasn't paying attention there, so we're gonna open this, and we're gonna check. Yeah, capital I. That's generally how I do it. Capital in the front, camel case, that sort of stuff. So there we go. Right. Player initialize. So when we launch the player initialize script, if the text of player state, if the text is equal to initialize, and we're going to trigger this once because we don't want it to infinitely loop. So we're going to trigger this one time. So when the player state is initialized, we're simply going to player, and then we're going to go to state, or not state, sorry, player text variable, set the player state to idle. So now the reason why I do this is it adds a buffer into our game. So when we launch the script, we make sure that the initialized script is working. And if it isn't, right? So if we press play and I press the plus button, I should be able to see that the player state is set to something. But right now, we don't have anything in there. So I'm going to show you now how to add things to your debug script. If you're making a small game, you might not need to add the player state variable to the player. You may want to add it as a global setting. So we're going to go to global variables, and this is across the entire scope of your game. This is probably for a project of this scale, you could do it here. So player state, right? And then we're just going to change that again to a string and call it initialize. And now, if I wanted to, I could change this from a player, and then we can in the condition write text, and it'll give us the various text inputs. And if you're looking at them underneath whatever you're searching, it'll tell you what type of variable it is. A general object variable is like a player or whatever sprite variable, right? There's global variables, which I just showed you, and then there's scene variables. Variables that are only accessible in that game scene preview, right? In that game scene. But globals are across the entire game. Scenes are only specific to that specific game scene, and objects are relative to the instance of that very specific object. So we chose originally a text variable. We chose the player. This is another way of doing the same thing I already did. Let me show you this. It comes out exactly the same, even though we selected, rather than selecting the player text variable and writing it, another way to do it, again, is write text, go to object variables, object variable, and then select the player, initialize it. But now we want to use a global instead. Clicking on the text available for a global, change it to player state, if it equals init, right? And we just got to make sure that we set the operator to equals. So now it looks a little bit different. It says if the global variable player state is initialized, do this task. Either way is good. I generally like assigning it to the player myself, but it's up to you. You can do it either way. I just wanted to show you how to do that. So now that we have the player state, though, I'm going to keep it on the player. And then what we're going to do is go into the game scene. Actually, we can do it here in the camera manager. So what we want to do is start addressing the player. So we're going to do, I changed my mind. I just told you we're going to do one thing, we're going to do something else. So we're going to link an external event, and now we're going to link the player finite state machine. And then all we're going to do is create an event group that says initialize the player. So now when we launch this script, we still, game scene is our choice, but now this is where we configure all of our player states. So we're going to create a new event group, and we're going to call it player states or player state router. You may, if you're familiar with like JavaScript and maybe React development or just JS. So player state. This would be player state machine router. Okay, and what we're going to do is we're going to route our actions. So, for example, we're going to create new groups for all of these actions. So player event. So we're going to say this is the idle state. Idle state. And when now we're going to set a condition. So when the player is in a animation, we're going to do animation by name because we already knew what we were going to do. We named them already idle. Okay, so when the animation is idle, what are we going to do? We are going to load our script. So when the animation, not that is not what I meant. Sorry. Wow. My brain shut off there for a second. We need to do not the, we're going to change the animation is one thing that we will be doing, but my brain was thinking about that while trying to teach you something else. So rather than starting at setting the condition, if we're playing the animation, what we need to do is go to the text variable. So player text, right? I already showed you a couple ways of doing that. We're going to change the if the player state is equal now to idle, we're going to enter the player idle script. Makes sense, right? So now we have a state controller. This controls when our player has when the text reads in the player state section as idle, which it does immediately after initializing the game. We've already told it to do that. Add text. And I set this to an array. I'm glad I just realized that I'd done that. We want to change the text variable, not add a text variable. So change text variable equal and set this to idle. Got ahead of myself. So there we go. So player text, player state. So if the variable of player state is equal to initialize, set the player state equal to now idle. Okay. Well, inside of our player state machine, we now have our router. So when we are in the idle state, run idle. When we are in the move state, now we're going to change this to move. I think we actually called it walk. So walk. And then we're going to change this to player walk. Player odd. Okay. Whatever. I guess I did call it move. I think I don't know. What did I do here? Player state, move. I think the animation is called walk, but I can change that at any point in time. You just want to be consistent here, but now you see what I'm doing, right? So when the text is this, we're always running this. We're always including this event. Yeah. So now we want to address the text. So we are changing the text, but we're not going to be able to see that text change unless we have something different in the debug manager. So we're going to click on debug manager in the game camera, shift D to create a new action, and we're going to put it just beneath at the beginning of the scene. We're not going to give it any condition. Okay? No condition necessary. We're just going to say, we're going to change the debug text, click on debug, and then click on text. And now we're going to change the text. So when we write text in GDevelop, something that you should know is that quotes means a string, but that's not the only scripting that we can do inside of here. So if we add a plus sign, that'll take a string. So right now it's an empty string. There's not even a space in there. If I did that, it would pass through a space and it would send that as a string. So it'd be a blank box except for one space. And so we want to make sure that that is empty, right? And then plus, and then we could write another string, okay? And these would add them together, side by side. So if I did 0 and then plus 0, it would be 0, 0, right beside each other. Because we're not adding numbers, right? We're adding text. And so what we want to do is go, let's say, player state, or we're going to call it state, colon, space. Because spaces, right, in strings have to be passed through, or there will be no space between the two. So the plus sign does not add a space, okay? It's just in addition to. And then what we're going to do is pass through a variable. And we need to pass through a variable as a string. Well, luckily, it's already a string. Because we set that for the player. So we type player, right? Hit tab. If player pops up here, we can click on it. You press tab, player, dot, what did we name it? Player state. So state equals player plus state. And because we added no condition to it, it's going to constantly run. So whenever this changes, it'll update in real time. So when we press the plus sign, right now we're in state 0. Why? Because we have no player. 0 is null. There is nothing there. There's no animation to choose from. It's empty. 0, the state 0 is so the player can't initialize because they're not on the screen. So if I added the player and we initialize the player and I press state at plus, we can now see that we're in the idle state, but we can't control our character, right? And I know that we could have just jumped right into creating a player script to get you started, but I want to teach you some really important fundamentals that'll help you in your development journey. So here we go again. Now we have the player. So we have a player, we have debug text, and nothing else. Okay? So we have the basics of our finite state machine. What happens when we're in the idle state? Well, we're going to go to the idle now. We're going to start adding our game logic. We're going to start adding and building upon what our player can do. So we're going to start with what we know our player is going to have to do first. It's better to organize with what you know you need and then fill it out rather than leaving it blank until you need it. So pre-built some structure for yourself. So what we're going to do is in the player idle format, what I want to do is when the player is in the state. So when player, and then we're going to go animation by name. When the player, I did this backwards again. So when the text variable is equal to idle. So if the animation of the player is idle and the player's animation by name, and now we're going to invert this. So there's two ways to invert something, right? So, but what we're going to do, so we can either click invert or we're going to leave it blank for now. And this says if the animation is idle and the text is idle, do something. Well, the player's animation defaultly happens to be idle, but that might not be the case if you add like a default or a blank animation first in the order. We did idle, move, jump, right? When we developed our player. But what we want to do is invert this. So we click on it and press J. This inverts the equation. And that's the same thing as clicking the invert button. So J quickly enables and disables. or inverts, not disables, inverts. So invert. So if the text of the player animation is equal to idle, which we already know, sorry, not animation. Wow, player state. That makes way more sense. I was talking about animations. Sorry. So if the text of the variable player state of the player is equal to idle, the animation of the player is not idle, then set the player's animation to idle. And we're going to do this every single time we enter a new state. So this is copy and paste code. Okay. In this case, idle. So this says, and we're going to do this once. So because we're looping the animation, we're going to trigger it once. And the text of the variable player state of player is equal to idle, and the animation isn't idle. Trigger this one time. We're going to change the animation to idle. And that's what I like to call our enter state script. So we have an enter state. We have a new event group called actions. Things you can do in idle state. And then we have another one. Whoops. I'm pressing the wrong keys. There we go. Transition? Did I spell that right? Transition. Yeah. And transition actions, or transition triggers. So we have actions, transitions, or we'll just call it leave state, actually. Leave state actions. I think that's the best. So we have can do actions and leave state actions. That's probably the best way to visually explain what's going on here. In idle, we ain't got nothing. We got bunk. We can't do anything in idle except for idle. So we don't need to do anything, right? So when we're in the idle script, do nothing. That's it. Can do actions, nothing. What can we do? Leave the state. So what we're going to do is create a new action, okay? And we're going to create a new event group, and we're going to call this one move. So if we move with our player, transition to the move state. Does that make sense? So in a finite state machine, we can only do the things we specify, and that's why it's finite. It's not ambiguous. It's very controlled. So now I need to show you how to make your own custom moving scripts. So this is what we're going to do. It looks complicated, but I promise you it's not. We're going to go to the event scene. We're going to double click on our player, go to behaviors. These are behaviors, and you may associate them with extensions. Behaviors are added elements that we bring in from an extension. So we're going to add a behavior, and the extension we want is platform character. And there's some video content if you want to watch that, but default controls says we're going to turn on jump, and we're going to give them the default control setup, which means GDevelop has some built-in control elements. So we're going to leave it as is. So I can show you how to set it up and why we set it up our way versus the way that GDevelop has it set up, and the flexibility with it. There's a lot of mumbo jumbo going on right here, but you don't really need to pay attention to that right now. We're going to hit apply. Now, if I press go, preview, our character is going to fall through the game world, okay, in like a second, right? So, I'll show you, but whoop, there he goes. He's gone. I don't know if you saw it, but he was gone. Gone. What's happening? Well, this is our preview, right? And what's happening is the player who's on the base layer is falling when gravity turns on, because we gave it gravity logic. Well, now we need collisions. We need to not fall through the map. So what do? We're going to go into objects, and I like to create a collisions folder. And inside that collision folder, we're going to add a new object. We're going to make it a sprite, and we're going to call this collision, okay? And we're actually going to make this with Piskel right now. So what we're going to do is we're going to set it to a 32 by 32 grid, which is too big. Actually, we're going to go 16 by 16. We're going to click down here to make sure we anchor to the middle. It doesn't matter when there's no pictures in it, but it could be important to you later. So we're going to resize it now to 16 by 16. It was very subtle, but there was a little bit of a click change that happened there. So now what we're going to do is grab the rectangle tool, click down here, and turn this to red. And we're just going to drag using that rectangle tool and create a red box. What I also like to do is take the pen tool, that's not right, the stroke tool, and create a box style element. Now, I showed you this, right? Collision. I'm going to show you this. I added this the wrong way because I want you to learn from this. So we have a collision sprite and we set it up properly. And now we're going to go to behavior, add platform logic. Ledges can be grabbed. We're going to turn that off for basic reasons. If you click on type, you have platform, ladder, or jump through platforms and ladders. And all of these actions are now built in. So if I had a ladder sprite and I pressed up on it using the default controls, I'd immediately start climbing it. That's built into GDevelop right out of the gate, as long as they have the platformer behavior. So we're going to say, okay, we're going to go to our grid now. We're going to toggle it on. So go to show grid. This is defaultly 32 by 32, which is much too big for our needs. We're going to change it by going up here, going to setup grid, changing it to 16 by 16. No offsets are necessary. Hit apply. And now we can snap our player and everything to a grid location. Now our player is bigger than our canvas. We don't want to shrink him down. That would not be good for our player. We want it to remain the same size. But we're going to drag our collision now. And now we have a collision. And we can hold left click or control left click and duplicate our collisions this way. And now if I do this, right, we've got all these objects that that we can interact with. And if we hit OK, we fall immediately down onto that object. And we can now see with the arrow keys and the jump key, we can start moving around. But the way I showed you the collisions is not the best way to do it. I want to show you a little hack that makes it a little bit easier if you're new to GDevelop. Real quick though, Funk, thank you for stopping by. I appreciate all the time you spent with us, and thank you so much for the support. It means the world to me that that you found value in what I'm making here and in the tutorials and stuff. So thank you so much for the love and support there. I'm looking forward to seeing you around. Make sure to join the Discord if you haven't already, and I'll see you around. Oh, there are special backer patron or like roles, ranks in Discord as well. So if you want to claim that, get over into Discord and I'll make sure that you have it. Okay, so what we're going to do now is delete the collisions. We're going to delete the collision object. I know, oh, it hurts. You sure want to remove it? We can't undo it. Yeah, we're going to do that. Because what we're going to do instead is add the object, go to a tiled sprite. This displays an image that's repeated over and over again in an area. And now what we can do is just by clicking here, inside the selected image, we can actually go through and select all of the sprites that we've already uploaded to our game, including those blue player sprites that I deleted. That's weird. Why is it in there? We deleted it. I'll show you in a second, but we're going to click collision and we're going to change this back to 16 by 16 and we're going to call it collision, right? Hit apply. Now, when we drag this down there, well, it looks exactly the same, doesn't it? It does. But now when we click on it and drag, it'll repeat itself over and over again. Now imagine for a minute that our player was the collision sprite like we had previously. If I was to stretch the block, this is what would happen. That's not good. We don't want that. So what we're going to do is just leave that down in the collisions. We're going to have to go back to our behavior, that's not the right one. We need to add the platform behavior, the very top one, turn off ledge grabbing unless you want it, and just set a platform, and that way our player doesn't fall through the ground. And now we have the basics of movement, right? So out of the gate, without any special tools, you could start making a platformer right now. We don't even need to control the game movement or anything like that. So I can open the game state, and when I'm moving left and right, okay, nothing's happening to the idle state. It's not registering that we're moving. Well, that's a problem because we want to leave the idle state. Right now we're in the idle state, but we can still control our character because the default game controls are enabled. So what we want to do okay, is we're going to go to player. We're going to go to behaviors, and we're going to turn off the default controls. We're going to hit apply, preview our game, and now none of the keys are working. But because we added the gameplay logic behavior, we can access its conditions and actions. So what we need to do is go into our player state machine and go into idle. And now we can start accessing those keystrokes. So before I told you, okay, to move, if we're going to check if any key is pressed. So this is an or statement. Okay. So, or if this happens, do these things. So if the key is pressed, okay, if what key is pressed, we're going to use arrow up. So it's just up. And key binding, so up, left, left and right. So anytime we press, in this case, actually we want to do left. So if we press left, and then we're going to duplicate this and double click it and change to right as well. So right and left. So if right or left is pressed, what do we want to do? We want to simulate. So simulate is the action that we're looking for to simulate us pressing a key, which means effectively press that key. But because there's baked in controls with top-down movement, we can either say the particular key we want, so simulate control, player, what key, up, down, left, right, behavior, but we run into some, or this is for top-down, there's platformer controls. We have a platformer, not a top-down, so we need to make sure we select the right one in the actions list, and this is kind of one of the difficulties of choosing an action, right? If we choose an action here, and when we type it in without finding it and scrolling through everything, we get this big input, right? So the more we know about the engine, the better we can navigate these tools. But for now, we're going to look for platformer behavior, platformer controls. As we can see, we have the behavior. It didn't flag us. Here it'll flag you if you don't have it. So here we have it, and left. That's one way of doing it, right? We could do it this way. The other way is player. Simulate. And now if we see when we click on the player, because we added the platformer controls, we now have them right here in the actions list. So we're going to say player left press. What's up, Ginge? So in this case, right, this would say if left or right is pressed, move in that direction. Well, we could do that. We could say, hey, if left is pressed, then move left. But that doesn't make sense, right? Because ultimately, if we touch any of the keys, we're transitioning out of the state, the player state. And so although this would work, like if we remove this, if we're in the idle state, right, and left key is pressed, then, and we could just move this out. So if left key is pressed, simulate moving left. So left key is pressed. Now look, I can move left, but I can't move any other directions. And so we could continue to do this. So right key and simulate right press. Oops, right press key. And this would now allow us to move left and right. But we stay in the idle state, which isn't what we want to do, right? We have an idle state, and then now we can see left and right. Well, we're not transitioning into our state. So we don't have finite control yet. This means that we're in the idle state, we can move. Well, we're supposed to be leaving our state, our player state. So what we need to do is instead say, and this is where we add that or. So if left or right is pressed, okay, instead of simulating a direction, we're going to change the text. We're going to say add player text, okay, change the text variable of the player state to move. And that's all we need to do. That's it. And we don't need to add another import from script because back here, we already loaded in that state. So you got to think about layers. We initialize our character, we move into one layer, which brings us into the player finite state controller, and then we move one more layer and move us into the management. So now, if we organize this right, if one of these keys are pressed, and we're in the idle state, transition immediately to the move state. Keep running this. If this is pressed, we don't need to do this one time because pressed is a single key. So as long as your key is being held down, it'll continuously do this. So we then know, as I'm holding this key into idle, honestly, it wouldn't, we're moving out of this state, so this will break. So when we move, this will break. So I'll show you. Turn this on. Now when I press left, we move. But now I can't move left and right. But we did go to the state move. So it's no different than idle currently. So now we need to go back to our player finite state machine. Go to the player move script. Choose game scene, right? And now we can do the previous events. I like to shrink this down, and for the sake of this particular video, I'm going to copy these, and we're just going to paste them in here. Okay? So we don't need the transition to leave the leave state in a move. We don't need this anymore because we instead can transition into idle and can do actions. Well, we can move now. So when we enter the state, we want to make sure that we change this and call this move. So when we enter the move state, and if the animation isn't walk, then set the animation to walk. Do that one time. So as long as we enter the state, boom, we're going to be walking. And the next thing that we need to do is can do actions. Well, we can move. So now we can add player controller, directional movement. And the reason why we're copying this stuff is eventually when we create more complex moves and behaviors, we can just copy and paste each of these sections into the other state. Because again, remember, finite state machine. Finite meaning limited, controlled number of actions. So by doing this, we go from idle, and if there's a key in press, go left and right. We can even if player move has a jump script, you can jump from while you're moving, but not when you're in idle for some reason. Then if we don't add the conditions of what we can do in this state, they don't transfer over. So before, when we had global settings, all the arrow keys moved the stuff around, shifted the player left and right, up and down, and space key worked. But now that we turned it off, it doesn't do anything because we haven't taught the engine, the machine, what it's allowed to do yet. Well, okay, so let's continue. So here we are. We're going to go into the walk animation, and when we're in walk, we're going to add a new event group, and we're going to call this one movement. And we're going to do the same conditions we had just done. So if player, key control press or simulated. So if the left key is pressed, move left. Now the left key is if the left key is pressed or simulated. And we could change this to all sorts of preset keys. This is tied into the default controls. We can use this. So if I go in here and now press left, we can see that we're moving, but we're not actually moving left and right, even though it worked. It's because, again, this key would be checking for this. So if the player has the left key pressed, simulate left press for player. Well, that doesn't work, right? Because we're saying the player is doing this action. That action has to come first. So instead, in the player movement, we go to player, and then now we check, actually, we type key, and now we look for that key being pressed, and we're going to look for the left key. And now if the left key is being pressed, simulate the left key press. I just wanted to make sure you guys saw the wrong way to do it, so that way you could figure out how to do it the right way, right? And so now we can do the same thing and change this to right. And if right key is being pressed, simulate the right key press. And now when we're in the move script, I can move left and I can move right. Left and right, no problem. Can't jump, can't do anything else, but this is the way we do it. So, sorry. Choking on air. Okay, so now that we have the ability to move left and right, we need to transition out of the move state. So what we can do is actually copy this key press, control click to copy the control press. We'd actually, I don't need to do that at all. Yeah, no, we do. So we can say, okay, if the right and left key isn't being pressed, that's not happening. Then we want to do what we did down here in the idle state and say if none of these keys are being pressed, not one or the other, if none of them are being pressed, change this from move, change the player state back to idle. So now we have a loop. So now when I preview and open the tab, we see we're in idle, left, and we move back to idle, right, move back to idle, left, right, We're still moving, okay, because we haven't let go of the key, but as soon as we let go, we move to idle. And then our idle controller takes over. And so what I've just taught you here is the fundamentals of how to do player finite state machines. So as a experiment, as I want you as a challenge to create the player jump external script using everything I just taught you. And if you can pull that off and get that functioning in your game, because I showed you already the animations are there. If you go through and you can add the jump mechanic and make it so you can jump in the idle script and the player move script and transition in and out of that state, then you're ready for your first game jam. And so this script right here, once completed and you have the jump mechanic implemented, you can drag and drop this and start developing for a game jam with player movement and controls already built in. It takes you seconds to copy all this over to your project. That's why it's so important to start building your essentials. Learn what you need to do to make a game. A game, if you break it down, is simply a bunch of features that get compiled and polished into one complete entity. So think about each thing you do as a feature. So we're making boilerplate code that is a basic feature, right? And you don't want to waste hours, days of your time recreating. I mean, we've been here for a couple of hours already. That's huge chunks out of your game development time. Why waste that? Be prepared. Build your boilerplate. So here I've showed you a basic boilerplate that allows you to move left and right. It'd be very easy for you to add another condition. Again, remember, we already have the external event made. If we want to, double click it, choose to add it to our game scene, and here you are. You need to copy the move or idle script over, and then you need to do some revisions to make sure that you can jump. But the key presses and transitioning states is already been done for you. I already showed you how to do that. You can do this. So I want you to do that. And then if you can, join us on Discord. Take a screenshot of you doing that and send it to me. I want to see your code. And this gives me an opportunity to give you hands-on feedback. So if you want help, if you need help, comment in the comment section below, join our Discord, share what you're working on. And that way we can start developing together. We can work together to solve all these problems. And I can help you navigate through basic coding structure. And so if you have any questions about how finite state machines work, how to better implement them with multiple player states, say you're making a Mario game and Mario's small and you know, when he's hurt or when he first starts out and he gets bigger, right? So we have large and small. Well, you can add those prefixes and suffixes in your debugger logic. So when we're at large size and we hit a block, break the block. If we're small size and hit a block, generate a coin. You see what I'm saying? And we can then use the debugger logic, the scripting way I showed you with the strings, building in so we'll go back to the camera manager, building in strings like this. Well, this isn't the only way we can pass through data. We can change our state machine just like this. So in here in our player finite state machine, instead of move, it could be small plus move. And small maybe underscore move with no spaces. And now it would report as, let me show you this. Okay? So if I change the idle script down here to change into what we just named it, small move, then when we code our game, small move would give us what we can do, our specialized movement. Maybe we move faster when we're small. Maybe we move slower when we're small. And that's how you could do that. And so you could check, you'd add another variable to your player. Okay, so you'd go into here, you'd add another variable, and you'd call it like size state, right? And we'd call it size state small. And so size state equals small. And so then in our text, if we were transitioning, right, we could say now, instead of move, it's now the player state is player dot size state plus player dot player state. So this would be small idle, small move, small whatever. And very quickly, see what I'm saying? You can generate and create extensive coding structures and organization that allows you to break everything down in really digestible and easy to manage loops and circuits. And that allows you to go back in and reiterate and move things around very quickly. Okay, so I want you to do the jump on your own and see if you can't figure that out and share that with me. Again, in the comment section below or in Discord. So that's your challenge to get started. And let's see. I want to make sure that I covered all of the basics that I wanted to. Let me pull up my document here. So some of the things that we might want to do is check, right? So when we're moving, how do we determine what's the difference between moving and falling? Can we move while we're falling? Well, all of those things, remember, can do actions, things you can do in that state. How to leave that state. So right here we have idle, right, for movement. But what if I wanted to jump? Well, then I need a jump script. Jump. And what key? How do we leave, right? Movement is what you can do without leaving. How we move. Like, so we want movement logic here, right? Or movement conditions. And then down here, we have leaving conditions. Leaving into idle, leaving into jump. So what do we need to do? When the player, or in this case, when the key is pressed, what key? Space, right? Space key. When space key is pressed, we want to transition to the player, or we want to transition the player to the jump state. There, I've done the groundwork for you to now transition into the jump state and make it work. Remember, the move conditions or the actions that you can do are how we can better define the area, you know, what we can do. So if we were making a jump script, we might also need a fall script. What happens when we're falling? And we can do checks like that. So what happens when we're falling? Well, we can say if the player, what is falling? If the player is falling, then we need to transition to the fall state. And so right now, instead of going to the jump state, right? I don't want to do that right now. But like falling, if we're falling in the movement state, say we run off a ledge, we need falling to be something that we can transition to. So falling has to have a condition. Jumping has to have a condition, right? So I'm going to delete these, but that's how you do that. That's how you transition into it. But now I want you to code it yourself. Add in all that logic. All right? And this works for move states, power-ups, all of that. You can control it here. So if we wanted to, we can go back to our main player finite state machine, or my favorite is in game mechanics. This is where I handle all my stuff. I like to add a enemy manager, right? Or enemy logic. We build all of our, maybe we'll play player to logic as well. So all of our enemy scripts can be in our enemy section, our player scripts, anything that you can think of should be here on the main scene. This is what breathes life into the rest of our thing. So here we have, again, enemy logic, player logic, camera events, empty scripts. Maybe we want, let's see. Maybe there's a world generation, right? But this is how you do it. World generation. Okay, now what? Well, import your world generation script, right? It's that easy. So now you've learned not only how to organize your code, how to change the color of your formatting. Say this is world generation. Maybe I want it to be green. Boom, green. Now I know that all of my green stuff is world generation. You can import logic from other scripts and bring them into your game and keep it organized and make it so that your crew, or your team, if you're working with someone, can help you. So that way they know what they're looking at. And this is a way of doing it with reducing the need for overused comments. You don't need to comment everything, but if it's at least visible, if it makes sense to do. So if you want to win in your next game jam, if you want to get into that environment and start making games right now, you need to have some basic understanding. And that's what we've done today. You've gone through being able to create scene objects, manage scripts, import, and use external events. I walked you through a little bit on how to make your character do some basic things. And that's just the tip of the iceberg. If you really want to see all the complex and interesting things that you can do, you can go to extensions, click on extension, and look at all of these community-made extensions. You can, some of them are officially supported, and some of them aren't, meaning that the official ones have been integrated into GDevelop and have the seal of approval, meaning that they work right now, they aren't depreciated, and the community extensions are not modulated. They get uploaded, but they may not be the cleanest code. They may break in some spots. They may not be fully polished, but they're still available. And there's tons of community extensions that aren't approved or reviewed and that are legendary to use. But some of the basic ones are health points and damage, firing bullets, controller support, mobile game support. All of those things can be very quickly added. And so I could show you here, we'll add life points, install it. Actually, I think the best thing to show you before I do that is going into the behavior and showing you, if I add a behavior and I type health, right? There's the extension, but there's no keys yet. So we need to add the health extension. Okay, so we're going to delete this real quick. Go back to apply, go back to we already added the health extension. But if I hadn't added that extension and you search, there wouldn't been anything there. Only what you add effectively will be available like that. So what that means is now we can go to our player, go to the behavior, and add this extension to our player, the object that we want to be able to do this. So we're going to add health. We're going to say that our starting health is 1 and our maximum health is 1. So that means, or there's no maximum. We just have 1 health. If we get hit, we die. So 1-1 doesn't matter. None of these other things really matter unless you want shield. Maybe your health regenerates over time. So say you're in a first-person shooter and you're out of combat for a certain amount of time or anything like that. And you have health regeneration. There you go. Armor reduces the incoming damage. All that stuff can be handled in the advanced properties. But for now, we're going to say that there's a 1-second cooldown and a starting life value of 1, and maybe the life maximum is 3, whatever. You could do it any way you wanted. But in this case, 1-1-1. So if we had more life, then we would get hit. There'd be a 1-second cooldown, and then we could get hit again. And we hit apply. And then we go to our game scene, and we can say enemy logic. When an enemy, we don't have an enemy yet, so we could add one. We can duplicate the player sprite, go into it, go to behaviors, it can have health too. Let's say that it has 1 health. It is a platform object, but it doesn't have any controls. That's fine. And let's see, we're going to delete all of these actions because although you might have similar ones for your enemy, I just want to show you this. Enemy. We're going to go to import images. And actually, we're just going to make it with Piskel. Sorry. We're going to go back and make sure that every time we open Piskel, it's 16 by 16, resize. And then we're just going to take a color, let's say orange-ish, orange-brown. And we're going to fill that in. And this is now the enemy. Enemy 1. Okay? Enemy 1. So now we have enemy 1. And we put enemy 1 on the game scene. And now in the game events, under enemy logic, actually, I want to do one more thing. I'm going to show you one thing I hadn't shown you before, and this is the objects group panel. We're going to open this, and we're going to add a new group, and then this one, we're just going to call regular enemy. And we're going to double click it, and we're going to add our enemy to that group. And so every time we add an enemy unit, we can add them to this group and create a hierarchy on how to manage multiple items at one time. So now we can say in our game event, in the player logic, if the group object enemy is in collision, so collision to the player, right? Player, apply damage, 1 point of damage. Shields and armors we can turn off because we don't have that support. So we could just say, hey, listen, if this happens, do this. And say, okay. Okay? So apply 1 point of damage, which will effectively kill us. And so in our player logic, in our player's finite state machine, we can create an overarching, we can call it death, right? So this is going to have a little bit of a different condition. In the death state, if the player's health points is equal to or is less than or equal to 0, so if it's below 0, right? Player, delete. Right? We could just delete the player. Or we can rotate. So rather than just deleting the player, we can also restart the game scene and go scene and say, change the game scene back to game scene. Stop any other pause scenes. Yes, because we're just going to make sure it resets. And that's it. So if the player ever dies, it doesn't matter what condition you're in. This has a no matter what happens. If this happens, we're going to reset. We're going to trigger this one time. Change the game scene. So now, if I die, boom, I reset. And now we have an infinite option here, right? If I run away from it, it's fine. But every time I touch it, I die. And that's basic enemy logic. Now, if you want to do coin collection, it would be a little bit different. So rather than collision with the player, right? This is when an enemy, all enemies, is in collision, but not for each enemy. So here we would want to do, we could type 4, or sorry, it's a right click on it, add for each object, for each enemy object. So for each instance of enemy, not enemy 1, for each instance of enemy, when the enemy is in collision with the player, deal 1 point of damage. So coin collecting would be the same way. For each instance of coin, if the coin is in collision with the player, add 1 to the score. Add 100. Do whatever you want. And that's reactions. So, or actions and reactions, basically. So conditions, triggers, sequences. Triggers, conditions or triggers. If conditions, right? If these conditions are met, for each instance of enemy, when that instance is in collision with a player, apply that damage. Now, on the enemy, we don't really need to do that. I think that just the standard collision with the enemy group, or enemy 1 is in collision with the player, then apply the point of damage. But this one is instance based, so this one is like basically already saying for each group of enemy, because it's in a group, and they're in collision, apply a point of damage. But if there's something happens and like they overlap and only one of them does damage, that's because you need a 4 each. But this is generally for like coins. So I was just showing you, like, this is what it would basically look like in structure if you're moving over into collecting. So again, for each instance of coin, if the coin is in collision with the player, apply, or in the opposite direction for each instance of heart object, for each instance of healing that the player is in collision with, apply a healing point of damage, or a healing point rather than, you know what I'm saying? So that's like the basics of that. And so now you could save this. Make sure you save frequently and often. You can have boilerplate code backed up and ready to go. And player finite state machines are a huge backbone for top-down and top-down isometric, you name it. This is used throughout the industry. This is a style of programming that really improves readability, and it's the only way that I teach programming. The way that I believe, especially with GDevelop, that you really should be focusing on good programming habits, and something like this improves readability, code function, and it makes it really easy to debug, right? Because then we can look at, well, like for example, if the player state never changed from initialize. So for example here, right? Let's say that this was initialize 2, for example. We put it preview and we turn it on. Well, we're stuck in the initialization script, right? Because that's what we set it to, but it's looking for something else. So we can see, well, we can't control our player. We're stuck in the initialize scene. So we can go back and go, oh, well, here we go. Initializing the player is kind of what we do here. But above that, oh, this isn't right, right? Look at that, easy debugging. And so if you want to jump into GDevelop and have a head start, you can start making all of these scripts because they're available publicly and it's within the rules of the game jam. Get your boilerplate, whatever ideas you have that are other code concepts that you want to incorporate. Maybe there's wall climbing. You can use our wall climbing extension. Maybe there's other features that you want to include in your game. Then you can pre-develop them as long as they're generic enough that they're not considered pre-planning in your game. These are mechanics that are available to everyone, and it doesn't make sense to reinvent the wheel. If you have to ask yourself, is this specialized code? Then it probably is, right? Specialized code is doing specific tasks, right? The way you, like reforming the way you dash or double dashing or dash, jump, movement, slow down, stuff like that. You can reuse some of those scripts, but you want to make sure that you're not developing assets with a particular game in mind. And it comes pretty clear, like when it's a generic script versus specialized. So make sure that you stay in the genre of general scripting and don't stray too far, because it could kick you out. You could get you disqualified from a game jam. And it's just bad practice, right? You want to make the everyday accessible scripts that you should know and have available to yourself whenever you need it. So you want to start a new project, well, you already have 3 other platformers that you've developed in the past. Why would you not bring that code over, then restart all over again? That's wasted time, unless you're doing it for practice or something else. But that's what boilerplate code is. Take the time to generate everything you need to make your game, or make general games, generic ideas come to life, and it makes it so that your prototyping is infinitely faster, right? And you become immediately valuable to every team you're on, because some of these people are so new, they also don't have boilerplate code. They haven't been in a jam yet and don't know what it's like. Now, we haven't even started on organization purposes, and I'm going to save that for my actual edit video. So what you're going to see differently between this, we're going to get all this digested down into a small category, or like get it edited down into a small digestible video that covers everything we've done in the shortest amount of time possible, but also will include how to set up a to-do list, like a Kanban or a Kanban, however you like to say it. The to-do tracking in progress, how to do that for free with your teams, and how to create pipelines, and also how to I lost my train of thought. Kanban, organization. Oh, and how to develop what we call a design sprint. So it's a very common word used in many different aspects of programming. And if you're new to the concept of a design sprint, or a sprint in general, it is quite literally a short jam that you do with your party, your friends, your team, whatever you're doing, your project team. And it's a short jam session where you spend some time doing ideation. So you're sitting with your team and you're developing the unique concepts of your game. You're discussing what your game could be, different ideas. And generally we won't know what our game's going to be like until the jam setting is announced. And then we can kind of start mentally preparing for the variations and expressing those creative influences in that genre that they're going to task us with. But then beyond that point, that's the ideation phase. So you're going to say, how do we make this game come to life that's based on slowing time, or time is a factor. Maybe our game's about growing old. Maybe it's about getting younger. Maybe it's a game where you can slow down time when you jump. There's so many different ways to interpret that knowledge. It's hard, or that understanding, it's hard to present it in a way that you can prepare for any game jam. It's not possible. That's why game jams like this exist. Not only that is, by the time you're done, you have a semi-polished product where you and your friends could go on to continue to develop it. So jams are important in developing your skills, and it lets you connect and work with other people in a way that helps everyone involved learn and advance their skills. So the next thing is a design sprint, right? So going back to that idea, you then sit down for one day, and hopefully not even the first day, especially if you only have 2 or 3 days to do it. But if you have a longer time, you want to plan each step of your journey. Plan it. Step 1, what are we going to do? We're going to sit down and ideate. We're going to talk about it. We're going to then prototype, right? So you go from ideation to prototyping, which means bringing those ideas to life in a semi-functional way to demonstrate what you can do or plan an idea. And then you go back into testing and then reiteration, which is kind of testing it, breaking it, figuring out what does and doesn't work, get user feedback, and go back and do it again. And that cycle is the repeat cycle that brings you to the end of a game jam. But knowing how to break those down into digestible ways depends on how much, one, your experience level, but how much time you actually have in the jam. So let's say you had a weekend jam. You got 2 days to work on this project to bring it to life. Well, we know, right, that we can't overplan our game. There's no way to fit all that content into such a small space. How do people make such robust games? It's because they have boilerplate experience. They have boilerplate stuff ready for them. So while you're wasting your time spending 3 to 4 hours getting your basic codes, they just dragged and dropped it. Took them 10 seconds. Now they're hours ahead of you. And that's why people are outputting higher quality and more polished things than you are. To some degree, they're using boilerplate code, or it's inevitable. You can't reinvent movement constantly. There's only so many ways to move a player around. It doesn't make sense for us to reinvent that every time and come up with some extravagant idea every time we want to go to another game jam. So the last little bits of advice that I have is, remember that when we're doing game jams, save your boilerplate in between all your jams, save all your coding and everything you're doing. That way you always have backups. Make sure you do the desktop version so you can save it locally and move it around and back it up so you never lose it. And there's no minimum number of those that you can have. It's relative to your hard drive space, right? And then also, when we're going through these next steps, when you're planning for a game dev jam, don't oversaturate yourself with too many ideas. You need to remember the scope of the project, how many days you have. Scope meaning like how many days, what the deadline is, what your development restrictions are, and all those other hurdles. If you guys are interested in the final edit of this video, there will be links to free and open source sprites if you want to use them and you don't want to use GDevelop. I've got loads of information on that. You go check out my YouTube channel and you can see ways to import your maps into other tools and use tile mapping software and integrate them into your game, and tons of other bootcamp information. So if you're seeing this video later, do check all that out. And if you're seeing it right now, in the next few days, I'll have an awesome video that condenses all of this stuff down into a very digestible video, and hopefully it'll save you lots of time and money. So If you found this helpful in any capacity, please leave a like, comment, subscribe, and join us in the next video. Go watch my other videos. If you haven't, also join us on Discord. Consider supporting me on Ko-Fi. I really appreciate those that have supported me. And every time I make a goal, I create a new asset pack for free on itch for other people to enjoy. So if you want to be a part of that legacy and you want to help more game developers like yourself get started and have solutions available right in front of them at one click for free, support me on Ko-Fi. Or Coffee, whatever. All right, guys, I need to take a break. I've been at it for too many hours. Much love. Thank you so much for hanging out and staying by with me. Remember, happy game making, and I'll see you in the next video.